Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about the fundamental concepts of graph theory. So, very first thing is that, so what is a graph? So, graph is nothing but a finite set of ordered pairs called edges, and then certain entities what we called as vertices, and these edges also called as arcs or links, whereas these vertices is called as nodes and then points. So graph is nothing but a finite collection of ordered pairs called as edges, and certain entities what we called as vertices. Then these edges also called as arcs or links, and these vertices are also called as nodes and then points. So cosine bridge problem is one of the problem in Persia. So in this city is going to be occupied by two islands plus areas on both banks. So how this problem is going to be overcome? So this thing should be solved through the concepts of graph theory. So here in this model, so the vertex, the region what is there in this one should be considered as a vertex, and then the path or bridge between the two regions is going to be considered as a edge here. So here and x and y, and x, y, and z, and then w. So these are the cities, and these cities are going to be connected by means of edges that should be the paths in between them. And so the cosine bridge problem is going to be represented in the form of a graph, and the graph looks like this, where each and every city is going to be connected by different edges and all. And general model. So here the vertex is nothing but an object, and then edge is nothing but the relationship between the two objects here. So what is a graph? So graph is nothing but a triple, consists of vertex set and edge set, and then the relation between the edge and then the pair of vertices. So here the vertex set should be capital X, Y, Z, and then W, and edges should be represented as E1, E2, E3, E4, E5, E6, E7. This should be the edges set. So the relationship is going to be represented between the two vertices is done through the edge here in between them. And what is a loop and what is a multiple edges? So loop is nothing but an edge whose endpoints are equal, then it should be an edge loop here. So here in this one, the edge endpoints are equal, so that's why the endpoints are equal, so that's why it should be considered as a loop. And multiple edges mean the edges have the same pair of endpoints. So this one what we called as a multiple edges. Then edge which is going to have the same endpoint, then it should be considered as a loop here. And whenever the edges have same pair of endpoints, so this is the endpoint and this is the another point which is going to be same. So that's why it should be multiple edges. And next one is that simple bar graph. So graph which has no loops on multiple edges. So this was called as a simple graph. And here, so this is the simple graph example. And in this graph, so the graph is going to hold loops and then parallel edges. That's why it should not be a simple graph here. So graph with no loops or multiple edges, so that thing should be called as a simple graph. And the graph which is going to have multiple edges and loops, then graph what we call it as multiple graph. Another example of the simple graph. So this is the another simple example of the simple graph, and this is also a simple graph. Whenever this graph is going to have self loops and then parallel edges like this, then it should not be treated as a simple graph. And next one is that adjacent and neighbors. So the two vertices are adjacent and or neighbors if they are endpoints of an edge. So example, A and B are adjacent and A and D are not adjacent. So what are the vertices that are adjacent means that there exists a edge in between them. So then I can able to treat that the two vertices or that adjacent here. So for the vertex V1, so V2 and then V3 are adjacent vertices. So in this one, A and B are adjacent, but A and B are not adjacent since there is no line in between them. So that's why A and B are not adjacent here or neighbor nodes. And what is the finite graph or null graph? So a graph whose vertex set and an edge set are finite, then it should be called as a finite graph. And graph whose vertex set and then edges are empty, then it should be considered as a null graph. So consider a graph. So I'm going to consider this is the graph, and these are the vertices. So whose this vertex set so are finite, so that's why it should be finite graph. And whenever the vertex set and edge set of this one so this should be the finite graph. So whenever the vertex set of the graph and edge set of the graph is empty, then it should be called as a null graph. So next one, complement of G. So what should be the complement of the graph? And the complement of the graph is represented by V of G dash, that should be equal to V of G, and a complement of edge set is also quite different of this. So whatever the edge that is present in the given graph may not be available in the edge of the complement graph. So in this one, so if I'm going to have like this, so this is the graph here. So this is a simple graph, and the complement of this graph is given by G dash. So this edge is missing, so this edge is removed and this edge are removed and this edge. So after removing these edges, so the edges what is present in this should be the complement of the graph here, and is denoted by UV such that UV does not belongs to edge of the graph G. And what is this QQ and then independent set? So QQ in the graph is nothing but set of pairwise adjacent vertices. And here an independent set in the graph is nothing but the set of pairwise non-adjacent vertices. So what is this QQ means that? So the set of pairwise adjacent vertices is nothing but a complete subgraph, and the independent set in the graph is nothing but the set of pairwise non-adjacent vertices. Suppose if I'm going to have then x, y, and then u should be this QQ pairwise adjacent vertices. So this should be called as QQ of the graph. An independent set means that U and then V should be entirely different. There is no connection between them. So that's why it should be the independent set of the graph. And next one is bipartite graph. So what is bipartite graph? A graph G is bipartite if V of G is the union of two disjoint independent set called bipartite set of the graph. And these vertices can be partitioned into two sets such that each set is independent. Okay. So and then in bipartite graph we are going to see two kind of problems like matching problem and job assignment problem. So a graph G is bipartite if that vertex set is the union of two disjoint independent sets, and these vertices matching problem means that. So this is one of the example of matching problem. So boys and girls relationship matching, and then job assignment problem. So in this job assignment problem, we are going to do how these workers are going to assign the jobs to the persons. So that kind of relationship will also be done through bipartite. And next one is that chromatic number. So what is the chromatic number? So the chromatic number of the graph G is going to be denoted as X of G. That should be denoted as the minimum number of colors that are needed to label the vertices, so such that the adjacent vertices receive the different colors. So the chromatic number of the graph G should be the minimum of colors needed to be labeled the vertices, such that the vertices should have different colors. So consider a graph. So I'm going to have a graph. So in this graph, I want to color the graphs in such a way that the minimum number of colors that are required to color the graph. So for this should be the chromatic number. Suppose if this one is going to be colored with color red, so this should be the red color, and this one I'm going to be filled with another color, let it be green. This should be red, and this should be blue here. So next here, red and green is filled, so that's why I'm going to fill with blue here. So what color I can able to fill with this? This should be the green, and for this I have to fill with red color, and these two are filled with. So here it should be blue, and these two is filled with. So I can able to fill with blue here. So what is the another color I'm going to fill in between this? Such the two vertices should not be have the same color. So if I'm going to fill with green, it should be okay. Yeah, it should be okay. So that's why. So the minimum chromatic number for coloring the graph is that 3x of 3. So these three colors are sufficient to fill this colors of the graph. And next one we are going to see what about maps and coloring. So map is a partition of the plane into two connected regions. So here you can able to color the region every map using at most 4 colors, such that the neighbor regions have different colors. So map coloring means that graph coloring. So the region is nothing but a vertex and adjacency is nothing but an edge. So the map is a partition of the plane into two connected regions. So where you can able to color the regions of every map using at most 4 colors, and the map coloring is nothing but the graph coloring where the region is going to be considered map and vertex is going to be considered in the graph, and adjacency is the another map coloring one. And next we are going to see what should be about the scheduling and then graph coloring. So the two committees can hold meetings at the same time, and if uh, two committees cannot hold the meetings at the same time, so if the two committees have the same common number, so then I can able to do that. So this is the committee one, and this should be the committee two. Both the committees are going to be filled with common member. So the two committees cannot hold the meetings at the same time, and if the two committees have the same common number. Scheduling and graph coloring. So the model is that, so one committee being represented by vertex and edge between the two vertices, and the two corresponding committees have the same common number, and the two adjacents cannot receive the same color. So scheduling and graph coloring is that, so one committee is going to be represented by vertex and edge is going to be represent the two vertices if two corresponding vertices have the same number, and two adjacent vertices cannot receive the same color. So this is the equivalent scheduling problem. This is equivalent to the graph coloring one. So in this one, I'm going to consider the two committees, and so these two committees are going to be filled by a common number, and it should be of the different. And next, we are going to see about what should be a path and cycle. So the path is nothing but the sequence of distinct vertices such that the two consecutive vertices are adjacent. And cycle is nothing but the closed path. That means where the source and destination should be same here. So the path is nothing but the sequence of distinct vertices such that two consecutive vertices are said to be adjacent. And cycle is nothing but a closed path. So where we can able to say that the source and destination should be same. So what is the path from A to C? So again, the path one should be A to B, B to C, and another path is that, so A to B, B to E, E to D, and then D to C. Or I can able to go that A to D, D to E, E to B, and B to C. So I can able to go from A to B, B to E, E to A, A to D, and A to C. So these are the different paths where I can able to go from A to C here. So for this, one of the path is that, so A to B and then B to C is the path. And another path is that, so A to B, B to E, E to D, and D to C is the another path. And one more path what I can able to say that is, so A to D, D to E, A to B, D to C is the another one. And another path what I'm going to say is A to B, B to E, C to A, A to D, and A to C. So this is the another path. So like this, the sequence of vertices is going to be formed a path. And cycle. So cycle is nothing but where the source and destination should be same here. Let us consider. So this is the source. So I want to reach the destination is also same. So for this, I'm going from A to D is the one of the path, and D to C, C to B, and B to E, E to A. So here the source is same and destination is also same. So that's why it should be forms a cycle here. And the thing is that B to E, E to D, D to C also forms a cycle. And A to B, B to E also forms a cycle. And next one is that subgraph. So the subgraph of a graph G is that V of H is subset of V of G and E of H is also subset of E of G. Then the assignment of endpoints, the edges H is the same as in G. So subgraph is that. So A to B. So this is the vertex set of G. And vertex set of H is given by so the edge set of G is given by A1, A2 up to A6. So the subgraph is going to be denoted by V of H such that it should be ABE. So this is the subgraph of the graph. Otherwise, E. This is also a subgraph of the graph. Otherwise, AED is under subgraph of the graph. EDC is also under subgraph of the graph. And edge set is also same. So the edge of H is given by E1, A2, and A3. Similarly, E4, E5, and then E6. So let us consider an example like this. We are going to have graph G, and here H1, H2, H3 are the subgraphs of the graph G. So CD is one of the subgraph, and AB, BE, ED, and E is also another subgraph of the graph G. And these two also different one. So this is under subgraph, and this is the under subgraph. And next one, what is the connected and disconnected graph? So there exists at least one path between the two vertices, then I can able to say that this should be the connected graph, otherwise it should be disconnected one. So here H1 and H2 are connected since there is a path from each and every vertex to the other vertex, and H3 is disconnected since there is no connection between this A to B and then A to C. And next one, we're going to see about what is adjacency, incidence, and degree. So assume that E1 is the edge whose endpoints are V1, Vj, and Vk, and Vj, Vk are said to be adjacent, and the edge EI is said to be incident upon. And degree of the vertex is neither number of vertices or number of edges that are incident on V1, and is going to be denoted by d of Vk. That should be the degree of that. So adjacency matrix is the matrix which is going to be defined by this matrix size of n by n, and is going to be filled with values either 0 and 1 if there exists a path in between them, otherwise there is no path in between them. So for w to w it should be 0, and w to x it should be 1h. And these are parallel edges, so that one is going to be represented with 2, x to y, and then y to x. So what is this incident matrix? So incident matrix is defined by n matrix in which each entry Mij is 1 if Vi is the endpoint of E1, otherwise it should be 0. So incident matrix is given by n by m matrix, which is where the entry is that 1, and if Vi is the endpoint E1, otherwise it should be 0. An isomorphic from a simple graph is the bisection. So f of f is nothing but v of j into v of k such that uv doesn't belongs to ez if and only if if f of uv is equal to f of eh. So isomorphic graph is the simple graph that should be a bijection. That means if for every edge set in the graph is equal to for every edge between these two graphs. And what is the complete graph here? So the simple graph whose vertices are pairwise adjacent, then it should be called as the complete graph. Suppose if I'm going to consider a graph like this, so for every pair of vertices there exists an edge connecting between them. And complete bipartite graph umbilical, that means is a simple bipartite graph such that two vertices are adjacent if and only if in different sets. So complete bipartite graph is simple bipartite graph. So that the two vertices are adjacent if and only if in the different party sets. And next one is that Peterson graph. So Peterson graph is the simple graph whose vertices are two elements subsets of five element subset and whose edges are pairwise disjoint two element subsets. How this one is going to be represented here is that suppose we are going to have the five elements and then the two element subsets will be like this. So 1 2 1 3 y 4 2 3 2 4 2 5 3 4 3 5 like this. So then I can able to represent 1 2 as one vertex and 1 3 as another vertex, 1 4 1 5 like this, and that should be connected with 2 3 2 4 2 5. So these are some of the other drawings of the Peterson graph. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.